In 5 billion years, our sun will begin its violent death throes, and Earth doesn't survive what comes next. But here's the disturbing truth. Our planet becomes a lifeless wasteland long before the sun ever reaches its final stage. Right now, our sun seems eternal. It rises every morning, bathes our planet in warmth, and powers all life on Earth. But this cosmic furnace that sustained us for billions of years is slowly burning through its fuel. And when that fuel runs out, our sun will transform into something monstrous. Deep in the sun's core, 4 million tons of hydrogen fuse into helium every single second. This nuclear inferno has been raging for 4.6 billion years, creating the perfect balance of heat and gravity that keeps our star stable. But hydrogen isn't infinite. The sun is already 30% brighter than when Earth formed, and it's accelerating toward a catastrophic endpoint. The first sign of doom begins subtly. As hydrogen depletes in the core, helium ash builds up like cosmic waste. This helium can't fuse at current temperatures, so it just sits there, growing denser. The core contracts under its own weight, heating up and causing the outer layers to burn hydrogen faster. Much faster. Here's where most people get the timeline wrong. The sun won't suddenly kill Earth in 5 billion years. The dying begins much sooner. Within just 1 billion years, the sun's brightness increases enough to trigger a runaway greenhouse effect on Earth. Our oceans begin to boil. Water vapor fills the atmosphere, trapping even more heat. Within 2 billion years, all complex life is extinct. Within 3 billion years, even the hardiest microbes are gone. Earth transforms into a hellish version of Venus, with surface temperatures exceeding 1,000 degrees Celsius, and the sun hasn't even entered its death phase yet. For the next billion years, Earth simply bakes, a scorched, sterile rock orbiting an increasingly hostile star. But this is just the appetizer for the main cosmic catastrophe. When the sun exhausts its core hydrogen completely, roughly 5 billion years from now, gravity finally wins its billion-year wrestling match. The core collapses violently, heating up to 100 million Kelvin. At these extreme temperatures, helium finally ignites in a process called the helium flash. This explosion releases more energy in seconds than the sun produces in 200 million years. But it happens deep inside the core, invisible to any outside observer. The real destruction comes from what this internal explosion triggers next. This marks the sun's transformation into a red giant, a bloated, unstable monster that will dwarf its current size. The numbers are staggering. Our sun will expand to roughly 200 times its current radius. If you could somehow witness it, imagine looking up at a sun so enormous it fills most of the sky. A wall of churning red plasma stretching from horizon to horizon. The sun's outer edge will reach beyond Earth's current orbit, potentially swallowing Mercury, Venus, and possibly our already dead home planet entirely. The inner solar system becomes an inferno. Mercury is consumed first, vaporized instantly as the expanding sun engulfs it. Venus follows shortly after, its thick atmosphere stripped away before the planet itself is swallowed by stellar fire. Earth's fate remains uncertain. Some models suggest our planet might barely escape consumption as the sun loses mass and Earth's orbit expands outward. But even if Earth avoids being devoured, survival is not salvation. The red giant sun will blast our planet with radiation levels thousands of times higher than today. Any remaining atmosphere gets stripped away by intense stellar winds. The surface becomes molten rock, glowing red-hot in the darkness of space. The planet that once harbored billions of life forms already dead for 3 billion years becomes a scorched cinder. The gravitational effects wreak havoc throughout the solar system. As the sun loses mass through stellar winds, its gravitational grip weakens. Planetary orbits become chaotic and unstable. Moons get ejected into interstellar space. The carefully orchestrated dance of planets that's lasted billions of years collapses into gravitational anarchy. Jupiter and Saturn might survive at their current distances, but they face their own transformation. As the Sun expands, these gas giants initially receive more heat, potentially warming their frozen moon. For a brief cosmic moment, perhaps a few 100 million years, Europa's subsurface ocean might melt through to the surface. Titan's methane lakes might evaporate into a thicker atmosphere, but this warmth is temporary, a cruel tease before the eternal winter that follows. But the Sun isn't finished with its destruction. Red giants are fundamentally unstable. The outer layers are so loosely bound that stellar winds begin stripping them away like cosmic hurricane winds. These aren't gentle breezes, they're violent streams of particles traveling at hundreds of kilometers per second, carrying away the Sun's outer atmosphere in massive, pulsing eruptions. Over millions of years, the Sun loses nearly half its total mass through these catastrophic outbursts. Each pulse sends shockwaves rippling through space, creating one of the universe's most beautiful yet deadly phenomena, a planetary nebula. Despite the name, planetary nebulae have nothing to do with planets. Early astronomers thought they looked like planetary disks through primitive telescopes. In reality, they're expanding shells of superheated gas, glowing in brilliant colors as they're energized by the dying star's radiation. The Helix Nebula, Ring Nebula, and Cat's Eye Nebula are all stellar graveyards, tombstones marking where sun-like stars met their end. These nebulae expand at incredible speeds, typically reaching 20 to 25 kilometers per second. Any remaining planets in the outer solar system get bombarded by this expanding wave of radiation and particles. The nebula sterilizes everything in its path, ensuring that no trace of life could survive even on the most distant worlds. The gas shell continues expanding for tens of thousands of years, eventually growing larger than our entire current solar system. From a distance, it would appear as a gorgeous, multicolored bubble of light, blues, greens, and reds painting the darkness of space. Up close, it's a lethal radiation storm that would instantly vaporize anything in its path. What emerges from this cosmic violence is perhaps even more alien than what came before. At the center of the expanding nebula sits the Sun's exposed core, a white dwarf star. This stellar corpse contains between 50 and 60% of our Sun's original mass, but compressed into a sphere roughly the size of Earth. The density is mind-breaking. A teaspoon of white dwarf material would weigh as much as an elephant. A sugar cube would weigh as much as a car. The surface temperature reaches 100,000 Kelvin, hot enough to glow brilliant blue-white, nearly 20 times hotter than our current Sun's surface. But without nuclear fusion, this is just leftover heat from the star's violent collapse. The white dwarf begins the longest cooling process in the universe, taking trillions of years to fade to black. For comparison, the entire universe is only 13.8 billion years old. White dwarf stars will still be cooling when the last normal stars burn out, when galaxies drift apart, when the cosmic microwave background radiation fades to nothing. They're the universe's ultimate survivors, slowly radiating away their heat in the cosmic darkness. Any planets that somehow survived the red giant phase now orbit this stellar ember in perpetual winter. Earth, if it still exists, becomes a frozen rock, drifting around a fading point of light. The temperatures plummet to near absolute zero. No atmosphere, no liquid water, no possibility of life. Just a dead world orbiting a dying star. Eventually, even the white dwarf surrenders to entropy. After trillions upon trillions of years, it cools completely, becoming a black dwarf, a cold, dark sphere invisible against the blackness of space. No black dwarfs exist yet anywhere in the universe. It simply hasn't been long enough. This final stellar corpse will persist essentially forever, a frozen monument to our sun's 10 billion-year lifetime. But here's what makes this cosmic story remarkable. We don't have to wait billions of years to witness this apocalypse. Every clear night you can look up and see dying stars in various stages of this same death sequence. Betelgeuse, the red supergiant marking Orion's shoulder, has already begun its expansion and could explode as a supernova sometime in the next few 100,000 years. Through a modest telescope, you can observe the ring nebula in Lyra, the ghostly remains of a sun-like star that died roughly 6,000 years ago. The Sirius system contains a white dwarf companion called Sirius B, a glimpse of our sun's future corpse, orbiting just 8.6 light-years away. Our galaxy contains billions of these stellar graveyards. Each one tells the same story that awaits our sun. Each one was once a stable star, perhaps warming planets, perhaps nurturing life. Now they exist as cosmic tombstones, monuments to the universal truth that nothing, not even stars, lasts forever. This cosmic apocalypse won't happen for 5 billion years, 25,000 times longer than humans have existed. But remember, Earth becomes uninhabitable within just 1 to 2 billion years, long before the sun's dramatic death throes begin. By the time our star swells into a red giant, our planet will have been dead for longer than complex life has currently existed. By then, humanity will have either spread across the galaxy or vanished entirely. But the sun's death is written in the laws of physics, as certain as gravity itself. In the grand theater of the universe, we're not just the audience watching distant stellar deaths unfold. We're watching previews of our own star's final act.